Find all the roots of x cube minus 6x square plus 11x minus 6 equals 0 using Graffe's root squaring method, performing the squaring only 2 times. Let us call this given equation as equation 1, whose roots we wish to find out using Graffe's root squaring method. Let us consider f of x equals x cube minus 6x square plus 11x minus 6. We have in f of x, there are total number of 3 sign changes. That is, considering the first two terms, we have sign has changed from positive to negative. Considering the second and third term, we have the sign has changed from negative to positive. Considering the last two terms, we have the sign has changed from positive to negative. Therefore, there are total number of 3 sign changes that has occurred in f of x. Hence, number of positive roots of f of x will be equal to 3. Or we have this given equation will have all the 3 roots being positive. The given equation 1 can be rewritten as x cube plus 11x equals 6x square plus 6. We have done the grouping such that we have odd power terms of x in the LHS and even power terms of x in the RHS. Thus, we have x multiplied to x square plus 11 equals 6 times x square plus 1. Here, when you make the assumption y equals x square, we have root y multiplied to y plus 11 equals 6 times y plus 1. In order to make this equation free of square root, we will square both sides of this equation and we arrive at this equation. We can expand both sides of this equation using the rule of a plus b the whole square. After simplification, we will arrive at equation 2. In equation 2, again we will do the grouping such that we have odd power terms of y left out in the LHS and even power terms of y along with the constants will be written in the RHS. Thus we arrive at this expression. Here we can rewrite it as y multiplied to y square plus 49 equals 2 times 7y square plus 18. When you make the assumption y square equals z, this equation can be rewritten as root of z multiplied to z plus 49 equals 2 times 7z plus 18. Here, in order to make this equation free of square root, when you square both sides of the equation, you get the equation z multiplied to z plus 49 the whole square equals 4 multiplied to 7z plus 18 the whole square. On simplification, this equation becomes z cube minus 98z square plus 1393z minus 1296 equals 0. Let us call this equation as equation 3. We have obtained equation 3 from equation 1 after performing squaring 2 times. Now we can stop the process of squaring because in question it is specified to perform squaring only 2 times. This equation will have roots beta 1, beta 2 and beta 3, which will be of the form beta 1 equals alpha 1 the whole raised to 4, beta 2 equals alpha 2 the whole raised to 4 and beta 3 equals alpha 3 the whole raised to 4, where alpha 1, alpha 2 and alpha 3 are the roots of equation 1, which is given by f of x equals 0. We have obtained equation 2, that is this equation, by squaring equation 1 for the first time. Thus, we have the roots of equation 2 will be gamma 1, gamma 2 and gamma 3, which will be of the form gamma 1 equals alpha 1 square, gamma 2 equals alpha 2 square and gamma 3 equals alpha 3 square. Since we have obtained equation 3 by doing squaring on equation 1 2 times, we will have this format of roots applicable. Usually we have the leading coefficient of such equations as 1, therefore b0 is always equal to 1. We have b1 is the coefficient of z square which equals minus 98 here, b2 is the coefficient of z which equals 1393 and b3 is the constant term which equals minus 1296. We have, in order to find out the roots of equation 3, the general ratios are beta 1 equals minus b1 by b0 which equals 98, beta 2 equals minus b2 by b1 which equals 1393 upon 98 and beta 3 equals minus b3 upon b1. Having obtained roots of equation 3, which are beta 1, beta 2 and beta 3, in order to find out alpha 1, alpha 2, alpha 3, which are the roots of equation 1 given by f of x equals 0, we have to raise the powers of beta 1, beta 2 and beta 3 to 1 by 4, so that we will get absolute value of alpha 1 equals beta 1 the whole raised to 1 by 4, absolute value of alpha 2 equals beta 2 the whole raised to 1 by 4 and absolute value of alpha 3 equals beta 3 the whole raised to 1 by 4. Taking 1 by 4th powers of roots beta 1, beta 2 and beta 3, we get absolute value of alpha 1 equals 3 approximately, absolute value of alpha 2 equals 2 approximately and absolute value of alpha 3 equals 1 approximately. Notice that we had already identified that f of x are having all the roots positive. Hence we have alpha 1, alpha 2 and alpha 3 will be 3, 2 and 1 respectively. In Graffe's root squaring algorithm, we will perform the squaring as many times as prescribed in the question. Maybe it is 2 times or it is 3 times. When you perform squaring only 2 times, we will have 1 by 4th power of root of the final equation will give us the desired roots of the initial equation. But if we perform squaring for 3 times, then by taking 1 by 8th power of roots of the final equation will give us the roots of desired initial equation. The general algorithm is that we rearrange the given equation in this way and the square term is equated to a general variable. We get a new equation in this general variable y. Again we do the grouping and again we have a square term which is replaced by another variable z. After squaring this equation, we will get an equation in z. If we were asked to do the squaring thrice, we would have done the grouping again here and equated z square to w. If the question was to perform squaring thrice. We have standard ratios which will help us to find out the roots of the final equation, and from the roots of final equation, we will identify the roots of the given equation.